In this example, we will find the measure of each angle in the triangle to the right. We will round each answer to the nearest tenth of a degree. In order to find the measure of each angle, it is typically recommended to look at a situation and at least try to consider working with the law of sines first. Now, I look at this situation and I do have some information. I have knowledge of what the value of the three side lengths here are. However, I unfortunately do not have any information about the angle measures. For example, I don't know alpha, so I cannot set up a full known ratio of alpha in the side across from it. So I can't use law of sines with that ratio to solve things. I also don't have beta, so I can't set up a ratio involving beta in the side across. And same thing with gamma. I do not have any full ratio here that will allow me to use the law of sines. So I'm going to need to use the law of cosines at least one time in order to find our angle measures here. Now, if we are going to find our angle measure using the law of cosines, we actually have many options to choose. We can choose to solve for alpha, beta, or gamma. It's really up to us in terms of which one we want to do. However, it is my recommendation that the angle measure that you should solve for is the largest angle measure. The reason for that is if you solve for the largest angle measure, then you will not run into any possible ambiguity later from using the arcsine function. When we use the law of cosines, which will involve arc cosine to find the angle measure, if the angle measure is supposed to be obtuse, we will know, and if not, we will know. If we know that the angle measure we're solving for is the largest one, then there is no possibility of getting anything even larger than that. And we should know, looking at this situation, which angle measure is the largest one, because it should be the angle measure that is across from the largest side length. So that means in this case, I would recommend to solve for beta first. To do that, we will use the law of cosines. The law of cosines working with beta, and therefore b, technically is the version of b squared equals a squared plus c squared minus 2ac times cosine of beta. The other ones would involve cosine of alpha or gamma. Since my goal is to solve for beta, however, if I solve this equation to get cosine of beta by itself, I will get cosine of beta is equal to a squared plus c squared minus b squared divided by 2ac. This is what I would get if I were to solve that law of cosines equation for cosine of beta. And in this case, I should be able to fill in my values on the right side of that equation there. In this case, it is just important to make sure that we understand that b here is the side that's across from beta. So we're going to be subtracting 12 squared. And then we'll put in the other values for a and c, which technically could be interchangeable. But for a, we have the side across from a is 10. So that's 10 squared. C, the side across from gamma, is 7. And then divided by 2 times 10 times 7. If we calculate that, that'll give us on top 100 plus 49, so 149, minus 12 squared, so 144. That'll just give us 5 in the numerator. And the denominator, I have 2 times 10 is 20, times 7 is 140. So I have cosine of beta is equal to 5 divided by 140. Now I don't know that ratio from the unit circle, so I'm probably going to need to use an inverse cosine function in order to solve for beta. Arc cosine of 5 over 140. Now I know this should be the largest angle measure, but I already know at this point that the angle measure I get is not going to be obtuse. This is because the input on arc cosine is a positive fraction of 5 over 140. If I had a negative, then I would be expecting a value between pi halves and pi, or in degree measure, 90 degrees and 180. So here, let's approximate arc cosine of 5 over 140 using a calculator. So inverse cosine of 5 divided by 140. Do make sure that you're in degree mode if you want to get a degree measure back, which we do here. This gives me approximately 87.95, or to the nearest tenth of a degree, would technically round to 88.0. So that is my value for beta. I now know, because that is the largest angle measure, that no matter what I get for alpha and gamma, they have to be smaller. So there is no possible ambiguity of maybe having another version of alpha or gamma. Furthermore, I no longer need to use law of cosines. Once I have one solid angle measure, then I now have a side length and an angle measure across, which means I should be able to use the law of sines moving forward. Let's say, for example, if I want to solve for the next largest angle measure, which would be alpha, because it's across from the next largest side length, I can set this up using the law of sines now. If I do so, this would look like sine of alpha divided by the side across from alpha, which is 10, is equal to sine of beta, which we now know is 88, divided by the side across from 88 degrees, which is 12. You very well could use arc cosine again if you wanted to, though. If you wanted to use the law of cosines to solve for the other remaining angle measures, by all means. But I personally see that as a little bit more work than necessary. I'm going to use the law of sines here, but depending on what you want to work on is on your comfort level. So I will use sine of alpha then is equal to 10 sine of 88 degrees divided by 12 when solving for sine of alpha. And then alpha then is arc sine of 10 times sine of 88 over 12. If I work with that, this will look like inverse sine of 10 times sine of 88 degrees. Again, make sure you're in degree mode. Divided by 12. That gives me, to the nearest tenth of a degree, 56.4. So that would be my value for alpha, the next largest angle measure. From here then, I only need to solve for gamma, and I again could use law of cosines if I wanted to, or if I could use law of sines if I wanted to, but there's no need. Since I now know two angle measures in this triangle, I could solve for the third, just considering that the angle measure of the triangle should add up to 180 degrees. So 180 minus 88.0 minus 56.4. That will give us 35.6. So that would be our values for alpha, beta, and for gamma in this triangle.